Hello students, today in this module we will discuss composite function. Composite function. Let f is a function from a to b and g is a function from b to c. F is a function from a to b, this is a, this is b. F is a function from a to b and g is a function from b to c. Then g of f is called composite function in which g operated on f of x. G operated on f of x. Here x, f operated on x, I'll get fx. On fx, g operated, I'll get g of fx. G of fx. So composite function is a function in which one function operated on second function. Like if I write down f of f, f of f, it means f operated on f. F of g, it means f operated on g. G operated on f, g operated on g. When one function operated on second function, that is called composite function. Suppose f is a function from R to R and let fx equal to 3x here plus 2x plus 1. G is a function from R to R and let gx is 2x plus 3. Now if I need f of gx, means f operated on gx, then firstly write the value of gx, 2x plus 3. Now this 2x plus 3, it will become domain for f. It will become x for f. So we have to put 2x plus 3 instead of x in f, and we get 3 multiplied by 2x plus 3 whole square, 2 multiplied by 2x plus 3 plus 1. Means instead of this x, you have to write down 2x plus 3. Now it is 3 multiplied by 4x here plus 9 plus 12x. Then 4x plus 6 plus 1. It is 12x here plus 12 plus 36x plus 4x plus 7. So it is 12x here plus 40x plus 19. It is f of gx. Simply see, if I need g of gx, same question, g of gx, g of gx. Then firstly find the value of gx. Gx is 2x plus 3. Now gx is 2x plus 3. This 2x plus 3 becomes x for g. This 2x plus 3 becomes domain for g. So in g, instead of x, you write down 2x plus 3. And then we get it is 4x plus 6 plus 3. It is 4x plus 9. So this is composite function when one function operates on second function. This is domain of f and it is range of f. Range of f is subset of domain of g. Range should be in the domain of g. Then we get g of fx. Second, suppose I have to write down f of fx, f of gx like this. F of gx exists. Condition exists when range of g is subset of domain of f. Range of g is subset of domain of f. F of f exists when range of f is subset of domain of f. Range of inner function should be subset of domain of outer function. Like we have g of fx, it will exist when range of f should be subset of domain of g. Range of f should be subset of domain of g. And lastly, g of gx exists when range of g is subset of domain of g. First function range should be subset of domain of f. fx domain range should be subset of domain of f. So first function range should be subset of domain of second function. Let us take one example. Suppose fx equal to e to the power x and gx equal to log x. fx is ex and gx is log x. If I say what is domain of this function, then its domain is R. It exists for all values of x. And if I say what is range of this function, range of this function is 0 to infinity. Range means answer. If I put 0 here, answer is 1. If I take minus 1, answer is 1 by e. It is positive. If I take minus 2, answer is 1 by e to the power 2. Positive. E is always positive. So its range is 0 to infinity. Its domain is R. Here, domain of this function is 0 to infinity. Domain is 0 to infinity. This x is positive number. Log does not exist for negative number. And range of this g, it is g. Range is R. Because logarithm answer is positive also and maybe negative also. So its range is R. Now if question is find out f of fx, f of gx, g of fx, g of gx. If question is this, firstly write down fx. What is fx here? Ex. Now this ex becomes domain for f. When it is domain for f, so instead of x, I have to write this. So it is now e to the power ex. Instead of this x, you have to write down e to the power x. Second, firstly write down gx. What is gx? Log x. Now this log x is domain for f. This log x is x for f. So instead of x, you have to write down log x. But e and log both are inverse of each other. They will cancel. Next, firstly write down fx. fx is ex. Then write down g. For g, this is x. For g, x. So instead of x, you have to write down ex. Again, log and e both are inverse of each other. They will cancel. I'll get x. If anyone knows this property, log n to the power n, then its answer is n log n. So its answer is x log e. And log e value is 1, therefore its answer is x. And lastly, firstly write down gx. What is gx here? Log x. Again g. Again I have to write log. So its answer is log x. Log of log x. Now, what is dot? This will exist when range of f is subset of domain of f. Range of f subset of domain of f. This will exist when range of g subset of domain of f. This will exist when range of f is subset of domain of g, and this will exist when range of g is subset of domain of g. This is the condition. Now see first, range of f subset of domain of f. Range of f should be subset of domain of f. It is true. Therefore, this is right answer. It will exist. Now come here. Range of G should be subset of domain of F. Range of D should be subset of domain of F. So this condition also satisfied. It will exist. See this. It will exist when range of F subset of domain of G. Range of F subset of domain of G. So this condition also satisfied. Therefore, this also exists. Now comes to last condition. Range of G subset of domain of G. Range of G subset of domain of G. Domain of G. So this R is not a subset of G infinity. So this condition is not possible here. So its answer is not this. Its answer is does not exist. Means G of G does not operate. Why? Range of G should be subset of domain of G. Range of G is not a subset of domain of G. This R is not subset of this. Therefore, this value does not exist. So its answer does not exist. You are not to write like this. So when we are to write, inner function range should be subset of outer function domain. So they are called composite function. See next thing. Next definition is identity function. Identity function. Any function from R to R is called identity function. Identity function. When f(x) equal to x for all x goes to R. If any function operate on x, answer is x. If any function operate on 1, answer is 1. If we operate on 2, answer is 2. If we operate on 3, answer is 3. If we operate on 10, answer is 10. For every number we are getting same answer. Then this function is called identity function. If any function operate on any number, if one function operate on any number, and we are getting same answer, then that function is called identity function, and we can write it as f equal to identity function. And if here set is R, identity on R. If f is a function from a to a and it is identity function, then we can write f equal to identity function like this. F is identity on a. It means for every element belongs to a, fx is x. For all x belongs to a. So if for every element fx equal to x, then f is called identity function. And if set is a, means if it is written f is iz, therefore f x equal to x for all x belongs to z. It is definition. Next thing. Let f is a function from R to R and g is a function from R to R such that two functions such that f of g equal to I equal to g of f. If f of g is I and g of f is I, both are I, or we can say f of gx equal to g of fx. If it is there, then first function inverse is second function and second function inverse is first function. If two functions operate on each other, and answer is I. If two functions operate on each other, answer is I. F of g is I, g of f is I. Then f inverse is g, g inverse is f. If f of f is I, because here two functions are different, f and g. So f of g, g of f both are I, then f inverse is g, g inverse is f. But if both the functions they are same, f of f is I, then f inverse is f. So So if composite function is I, then both are inverse of each other. F inverse is G and G inverse is F. If F of F is I, F inverse is F inverse is F. See one example. Suppose fx equal to 4x plus 3 upon 6x minus 4, where x not belongs to 2 by 3. It is given. Question is find out f of f and hence find out f inverse. Firstly find out this, then find out this. So first step, I have to find out f of f. So I will start f of x. It is equal to f of fx. Firstly write the value of fx. It is 4x plus 3 upon 6x minus 4. Now this whole value, it will become x for this f. So wherever there is x, you are going to write this value. So it is 4 multiplied by 4x plus 3 upon 6x minus 4 plus 3 divided by 6 multiplied by 4x plus 3 upon 6x minus 4 minus 4. So instead of x, you are to write on this value. Let us take LCM. LCM is 6x minus 4 here, 6x minus 4 here. When I take LCM, it is 16x plus 12. And when we take LCM, 3 multiply here, I'll get 18x minus 12. In the denominator, when I take LCM, it is 24x plus 18 minus 4 multiply here minus 24x and minus 4 multiply here 16 divided by 6x minus 4. This 12 also cancel, 24x also cancel, and I'll get 34x divided by 34 in the end x. It means its answer is x. And when f of fx answer is x, therefore f of f is I. And when it is I, therefore f inverse is f. If composite function is I, then first function inverse is second and second function inverse is first. Question is find out this and hence find out this. So you are not to prove 1 1 1 2 like this. Directly from here you can write f inverse is f. F inverse is this f. When composite function is x, it means it is I, and when it is I, f inverse is f inverse is f. See one more example. Suppose f is a function from R to R such that fx equal to 3 minus x cube whole power 1 by 3, and question is find out this. This is a function that is given to you and question is find out this. So again I have to start f of fx. It is f of fx 3 minus x cube whole power 1 by 3, and now this whole value it will become x. So wherever there is x, you are to write on this. Now read this, it is 3 minus x cube whole power 1 by 3. So again I will write out 3 minus this term cube x cube, it is x cube whole power 1 by 3. 3 minus this term cube whole power 1 by 3. Now this 3 and this 3 it will cancel. It is 3 minus 3 plus x cube whole power 1 by 3. It is x cube whole power 1 by 3. So its answer is also x. It means I can say f of f is I. If question is find out inverse, then I can say f inverse is f. So when we are to find out f of f composite function, firstly write down value of fx. This value will become x. Treat it as x. Treat it as domain. Instead of x, you are to write down this value and then find the answer. Let us take one question more. Suppose question is f is the function from R to R such that fx is signal function. What is signal? It is 1, 0, minus 1 when x is greater than 0, when x is equal to 0, when x is less than 0. And g is any function from R to R such that gx is greatest integer. What is this? Signal function. What is this? Greatest integer. Now question is whether f of g and g of f coincide in 0 to 1. This is the question. Whether f of g and g of f coincide in between 0 to 1. 0 open, 1 closed. F is this function, g is this function. Whether they will coincide. Coincide means whether both have same value. And interval is from 0 open to 1 closed. We are to exclude 0 but include 1. So we are to take two cases. First case, when x equal to 1. And second case, when x lies between 0 to 1. 1 separate and 0 to 1 separate. And question is f of g, g of f. So find out f of g at 1. Find out g of f at 1. And then for these values. Now firstly, f of g1. We are to write the value of g1. See, what is g1 here? If I put 1 here, I will get greatest integer 1. Greatest integer 1, answer is 1. Now when we f1, 1 is domain. Domain 1 lies here. Because it is domain x greater than 0. And it is greater than 0. So its answer is 1. Again see. Firstly find out f1. So I have to see f. And what is domain here? 1. 1 is here. So its answer is 1. Now I need g1. g1 when I put 1 here, again 1. So f of g, g of f both are same value when x equal to 1. Now we take x belongs to 0 to 1. 0 to 1, excluding 0 and 1. It means all the numbers 0.1, 0.2, 0.3 like this. So we have to find out f of g for all values from 0 to 1 and g of f all values from 0 to 1. Here x is all values from 0 to 1. Firstly, write the value of gx. Now when x lies between 0 to 1, 0 to 1, excluding 0 and 1, it means 0.1, 0.2, 0.3. If I take 0.1 here, 0.2 here, 0.3 here, its answer is 0. So its answer is 0. Now I need f0. At f0, 0 is domain. Answer is 0. Let us find out firstly fx. Again, x lies between 0 to 1. When x lies between 0 to 1, value of fx. Value of fx. They are the values. When x lies between 0 to 1, x greater than 0, answer is 1. And it is x greater than 0. So answer is 1. So its answer is 1. Now I need g1, put 1 here. And when I put 1 here, answer is 1. Because greatest integer 1 is answer is 1. It means f of g and g of f, they are having different value. And therefore, in the answer, f of g and g of f do not coincide in 0 to 1. This is the answer. So see again, f is signal function, g is greatest integer. I have to find out f of g, I have to find out g of f. They are called composite function in between 0 to 1. We are to exclude 0 but include 1. So we are to start at 1 arc separate, at 0 to 1 separate. This is open interval. Find out f of g, find out g of f. If both are not same, therefore f of g and g of f, they do not coincide in 0 to 1. So this is small lecture about composite function. Okay, this is from my side. Wait for next video. Thank you.